My name is Shiraj. I teach a couple of classes in edureka, including data science and Mahout and other things. And I've been working in IBM Research in California, IBM Research Labs. Uh, and I'm in the area of big data and data science for more than 10 years. I have done my PhD in data mining, which is kind of a close cousin of data science and machine learning. And yeah, my daily job is basically to research on new ways of doing analytics and creating system support for doing large-scale data analytics. That includes data science, obviously. And yeah, that's briefly about me. And in today's session, we are going to basically get kind of introduce ourselves to the world of data science. Okay, and hopefully by end of this hour, I'll try to convince you guys to kind of venture into this new field of data science, which is probably closely related to some of the things that you have been doing in your daily life, or it may be completely new as well. Okay, but nevertheless, I promise you it's going to be a promising journey for you uh, if and when you choose to join this new field. Okay, so without further ado, let's begin the actual session. And as I was telling you, we'll first talk about what exactly is data science. I mean, why there's new fuss about all this buzzword. And then we'll understand what exactly is it and what kind of opportunities are there in the market. And we'll also see how different companies are trying to leverage this data science in order to kind of increase their revenue, reach out to their customers and whatnot, right? And then at the end, I'll show some little demo of one particular application within data science, which is primarily used in many organizations currently. Okay, so with that, I hope I'll give a good introduction to data science. But feel free to ask me any question. You know where to type in your question. Since it's a general webinar, I will not be able to take the questions on air, so you cannot speak directly to me, but you can type in your question in the questions window, and whenever it is appropriate, I'll answer it. Okay, and you can ask me anything relevant to data science. Need not be exactly what I'm need not be exactly related to what I'm talking. Okay. Okay. So uh, we've been hearing, I'm sure you would also heard saying that data scientist is this new magical role, and everybody is touting that as sexiest job in the 21st century. Okay, and let's see why exactly people have said that and what's the kind of the truth behind it. And oh, by the way, at the end of the session, I'll open up for general questions as well. So if you have a completely general question, please hold off until the end of session, and we'll have as much time as possible for the Q&A. Okay? Okay. So, uh, I mean, yes, it's a sexiest job in the 21st century, but also it's becoming a dream job for many people, starting from experienced professional, uh, from fresh graduates out of universities, right? And in fact, again, some of you have already know that many universities in US are already having curriculum developed around data science, right? Just like you've been hearing about degrees in computer science, mechanical engineering, bioinformatics, and so on. Now you can get a degree like a full-fledged academic degree in data science. Now, think about our lifetimes, right? How often did we see um, a new science or a new degree being created in our entire, I don't know, last 30, 40 years, right? Probably, at least in my lifetime, I remember only biotech being the new field that was introduced to the regular curriculum of computer science and mechanical and blah, 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 at least in the space of engineering. And now I'm seeing a new thing, which is data science, right? So that won't come very often. At least that should kind of corroborate the fact that it's going to be there for quite a few years down the road, right? And many people, I mean, if you read any article on data science, you will see that lots of numbers. Again, you can take them with a grain of salt as well, saying analytics and data science as a multi-billion-dollar industry in the coming years, right? And one nice thing about data science is it's kind of closely related to what people have been doing in various different industries, right? Starting from data analysts, which are a standard job description in the context of databases and analyzing data that is stored in databases, right? And it's kind of, you can think of that as an extension. And it's also related to like the core systems engineers, systems programmers who have been developing software in order to facilitate data analysis that may be based on databases or not based on databases, right? But core system engineers. So it's not only relevant to the data analysts, it's also relevant to the programmers. And moreover, it's also relevant to the functional experts, right? Like in the context of SAP and Oracle Business Suite or whatnot, there are lots of functional guys who are very, very familiar with the actual businesses. They need not be like coding Java programs day and night, but they know the business very well. So they can take business decisions, they can try to create a solution for a given business problem and so on. And data science is relevant to those guys as well. So, so that's kind of a nice thing because whichever domain you are working in currently, chances are it has connections to the data science, and therefore you have a chance of venturing into this new field. Okay, and I'll tell you a little more about that later on, how these different domains kind of come together in the space of data science, right? And not surprisingly, because of various reasons, these companies have been inundated with lots and lots of data. I don't need to lecture on big data at all, because I'm sure you would have already been convinced that data is there, right? Data is the new resource, like water, like sunlight. Data is considered being a new resource for businesses, right? Now, it's all up to organizations how exactly to make something out of that data. And that's where exactly data science come into play. And you will see lots of charts like this saying that basically data scientist role as a new job description is growing in popularity, right? And this particular slide tells you that it's kind of the best, one of the best new jobs, at least in Americas, and I'm sure it's across the world as well. Okay, and another nice thing, obviously, ultimately we work, even though we are passionate about work, we need money, right? Of course, for surviving. And good news is that data scientist role has basically bumped up the average salary in many different uh, um, these related domains that I was talking about, right? Like, for example, if you take California, A recent study showed that average salary is about $105,000 per year, right? And the range is pretty large. You will see entry-level data scientist positions about 80K and 85K as well, ranging up to close to 200K as well, right? So depending on uh, lots of different things, right? Depending on the candidate's experience and the company, the criticality of that role, based on lots of different things, the range matters, but the average salaries are significantly higher than average salaries of other related positions. Like for example, if you're familiar with data analyst area, you can compare average salary of a data analyst with data scientist, and you will be able to see the differences then. And this is not just across like a technology friendly Silicon Valley in California, but it's across the board, right? At least in US, which is where the study was done. Even like South Dakota and North Dakota also, there are lots of positions. And the reason being data science, right? It's all about science on the data, and data has no domain, right? You take retail, you take healthcare, you take petrochemicals or oil industry, any domain that you take, you can collect data. And in fact, they have been collecting data. And therefore, analyzing the data kind of cuts across all the domains. And that's why even states like North Dakota and South Dakota, where oil, for example, is the main business, right? In North Dakota, oil is the main business. And even there, you can find positions because they have data. In fact, they have uh, uh, treasures of data, right? Because the data tells you uh, where to drill so that you can get oil, most of the oil, right? So, so since data cuts across all the industries, you will see data scientist positions in various different industries and therefore across entire country, right? So it's kind of pervasive in that sense. Now, again, we can talk more and more about salaries and types of um, growing set of roles and so on. But ultimately, what exactly is data science, right? Yes, I mean, we have been hearing so much about jobs and being the sexiest job and whatnot, but who cares? Ultimately, what exactly is data science, right? And I would like to sum up the entire data science as this one line. Data science is all about extracting meaningful and actionable knowledge from the data. Okay, and similar definition you will also see in the context of data mining, but kind of they're all ultimately talking about the same thing, which is extracting something interesting, something innovative from the data that you have. And this knowledge that you're extracting should be meaningful, obviously, otherwise nobody cares, right? And it's actionable. Actionable meaning after getting that knowledge, you should be able to act upon it. You should be able to do something from that knowledge. Like for example, if you take a data scientist in working in government, then the knowledge that you extract from these public data sets about energy or some other thing, maybe government um, will be able to take some policies, right? Maybe depending on the energy usage and stuff like that, maybe they want to create a new renewable energy plan going forward in the next 5 years or 10 years, right? So so the knowledge that you extract is kind of affecting the way the policy is being written, right? So that's the actionable item that you get out of the knowledge that you gain from that data. And similarly, let's say a retail company once you extract knowledge, maybe they can create a new recommendation strategy from the knowledge that you kind of gleaned from the data. Or a bank, for example, maybe should be able to create a new financial product targeting a particular class of customers, for example. Or a telco company may be able to create a new kind of a calling plan targeting some set of users in their cellular network, right? So whatever that is, whatever that action is, it depends on the domain, it depends on the application and so on, but ultimately it should be actionable. You should be able to take some action because of that knowledge. Otherwise, yes, it's interesting fact, but ultimately it doesn't help me grow in my business, it doesn't help in government to create a new policy, then doesn't help, right? It's just an interesting fact and people will move on unless it's actionable. So data science is about extracting meaningful and actionable knowledge from the data. Okay. And so that's kind of a very, very 10,000 feet high definition of data science. Now, you may be thinking, I mean, this is not new. People have been using data for a long, long time, right? Banks, even if I take banks, I mean, they have data for a very long time, and they have been uh, doing analytics for a very long time as well, right? And that's why we have positions like data analyst for many years until now. So what's new, right? In fact, there's nothing new. And that's why I call it this other line, I have it here. Data science is new, but data science isn't. So what I mean by this oxymoron is that, yes, analytics of data and extracting knowledge from the data has been there for a very long time, right? But it has been there only for selected companies, handful of companies, right? Like high-end banks or insurance companies, or some specific government labs and so on, right? Only these handful companies first of all, they had the capability of collecting the data, and not only collect, but they had the capability in the sense of manpower as well as systems architecture to store and manage the data, as well as they have enough um, kind of people with very skilled labor that can work on that data and extract something meaningful, right? For example, take Google, right? It's a classic example. So Google, what have they done? Those two guys, Larry Page and Sergey Brin. Of course, they created a new search engine, but Google was not the first search engine. Before that, there were some attempts to create a search engine as well, like Alta Vista, right? Which is a search engine which was just based on the content. You type in a word and it simply searches for the word in a bunch of web pages that they have crawled, and then they show them as a result. Okay, I mean, I'm simplifying it, but it's pretty much like that. But then these two guys have seen, oh, web pages is not just about the content. There's actually hidden trove of information in the connectivity that they have within the web pages, the hyperlinks between the web pages. And they said, these two guys, they said that, oh, if all the web pages are referencing to one page, let's say CNN.com, if everybody is referring to CNN.com, then CNN.com should be containing some useful information compared to other web pages. That's why everybody is referencing it. So by looking at this link information along with the content, you can actually create a better search ranking. And that's how they came up with this page rank. right? So that was the underlying intuition. Now from there they created a mathematical technique, or they used existing mathematical techniques to formulate that problem, and they created this new ranking scheme called PageRank, and that helped in creating better search results, and from there onwards Google was born, and we know where it is right now, right? Again, I'm simplifying a lot of things, but the point is they were able to extract something actionable in terms of search engine ranking, for example, from the data that they have, and the data being the web pages. So what Google has done is exactly data science. It's just that it was not called data science back then. And that's why I said data science is new, but it isn't. It's new because the pervasive nature of data science in the current day world. Previously, this kind of massive amounts of data or the interesting types of data was being collected only by these handful companies. But now, you know that every little organization, every society in the world is being able to, has the capability of collecting and storing the data. And obviously, they want to make use of it and to grow their business, to grow their organization, or whatever is the need, right? So because of that um, uh, democratization of the data, the problem of analytics and extracting something new has become much, much wider and much, much bigger than what we have seen in a couple of decades ago, right? So that's why the data science is new, but the actual concept of data science is not. Okay? Does that make sense, everyone? Okay, very good. So with that, so remember previously I was kind of alluding to the relationship between multiple different domains, and the slide tries to capture that uh, interdependency across multiple fields of study that data science is bringing together, right? Like for example, you need the data science is a mix of all these five different things. Okay, like for example, it requires statistics or mathematics. You can call it whatever you want, but the idea is the core fundamental mathematical techniques that are required to analyze your data, right? Like for example, in the Google example that I just told you, there's a fundamental mathematics behind this page rank, which is simply algebra with matrices, right? It's called linear algebra, which we all studied in high school. It's just some matrix computation. You have rows, you have columns, you have vectors, you multiply them, you transpose them, blah, 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 and then magically you get ranking, right? So the entire page rank, actually, you can just describe it in math in like 5 or 6 lines, at least the main idea of page rank, right? So that's the statistics or mathematics or machine learning, all that falls into that category, that bucket, this bucket, which is the core fundamental techniques to analyze the data, right? But that alone didn't bring Google to the stage where it is right now. It has accompanied that core mathematics or core technique is accompanied by lots of other things, like for example, data engineering, which is to say that data engineering is responsible. Again, the labels can be different. I mean, people call it data transformations or data pre-processing and whatnot. But the idea behind the data engineering bullet is that converting your raw data into a form in which you can start applying your mathematical techniques, right? So this PageRank algorithm is there. Let's say I read it from my textbook. It's nice little 6 line of equations. Okay. But how can I apply? Where should I, on what data should I apply it? I cannot apply it directly on the web page that I just downloaded from internet, right? Because that web page is very, very dirty. It has some HTML, it has some XML, it has some images, it has some tags and whatnot, right? It has some advertisements. It has all sorts of things in it. And I cannot apply my mathematical equations on that particular web page. I have to clean it up. I have to transform it. I have to massage it in the form that that I can start applying my mathematical techniques that I created, right? So that's the data engineering part. And people who have been working in databases and stuff, that's like ETL, extract, transform, and load, if you are familiar with that, right? Which is essentially converting raw data into the form in which you can start applying your techniques. So that's the data engineering. Without that, however cool your mathematical technique doesn't help, right? You don't know where to apply. So data engineering or the ETL kind of people are related to data science as well, because it's an integral part of data science. But story doesn't end there. You need, like, again, taking Google as an example, initially, when they started in 96 or 98, the internet was very, very small with only maybe thousands of web pages. But it has grown significantly over the time. We now have millions of web pages and there are billions of edges between the pages, right? And previously they were able to crawl and analyze the entire internet using a couple of machines in their DOM. But those couple of machines cannot handle millions of web pages that are available today. So along with the data, you need to scale up the underlying infrastructure as well. You need to make it bigger, right? So that you meet the demands of the growing internet size, right? I mean, Google does a lot of different things, but just keeping search or page rank alone in the picture, you can already see the need for scalability, the need for being able to handle these, I don't know, terabytes or petabytes, whatever is the number, so much data, right? So just having mathematical equations, cool mathematical equations, and having very nice ETL pipeline doesn't help. You need to be able to make them grow bigger on big data as well as on larger set of machines. And that's where your advanced computing comes into play. Again, you can call it distributed computing, scalable computing, whatever you call it, but the underlying idea is that you need to be able to scale, right? And along with these three, you also need something on the visualization, right? Especially, I mean, there are a lot of times you can analyze a trend just by looking at a chart, right? I mean, as people call it, a picture worth a thousand words. So if you just draw one chart, it can tell you the trend and lots of different things than just looking at a table of numbers, right? So from the presentation perspective as well as analyzing perspective, visualization uh, is kind of the underlying current in data science. Now, along with that, you also need domain expertise. This is where I was relating to the functional experts or the people who understand the business, right? That's also important because without that, you cannot really make sense out of the data, or you cannot uh, go through the data or navigate through the data in a more efficient manner. Like, for example, as a data scientist, I can join, for example, a healthcare company. Okay, let's say I join Anthem or Kaiser, which is a healthcare provider, and they hire me to analyze their medical data sets. Okay, maybe I have to create a new predictive model to assess people's risk of having diabetes. Okay, a patient comes in, they have their health record with it, maybe their blood profile, I mean the blood test result, glucose test results, and BP, and blah blah blah, cholesterol, and whatever doctor recommended them to go through the testing. I got all the results. Now, using all those results, I have to make sense and predict whether that particular patient has a risk of diabetes or not. Okay, very simple problem setting. But will I be able to do that? No, unless, so I know very good mathematics. Okay, I can create very cool techniques, and I have super experience with creating pipelines of data transformations. And also, I recently learned Hadoop, and I can scale things to a large data sets as well. But still, I cannot deal with that problem because I don't know what this data is. I don't know what sugar is. I don't know what's glucose level related to diabetes, whether glucose is related to diabetes or cholesterol is related to diabetes. I don't know. Only the domain expert knows. Only the doctor knows that, oh, in order to analyze diabetes, research from years old in the medical domain have shown that something like body mass index, glucose concentration, or your work ethic, or your pedigree, that means hereditary information, all that will play a role in determining whether somebody has a risk of diabetes or not. So the domain expert will tell the data scientist that, oh, these are the factors that are involved. Oh, by the way, the last year recent study showed that, I don't know, the stuff that you eat is linked to the diabetes. So try to incorporate that data as well in your analytics. That's what the domain expert will tell the data scientist. And only then I will be able to, as a data scientist, I will be able to combine all these different factors that the domain expert is telling, and then make sense out of it and create a model, and then predict that that patient has risk of diabetes or not. Right? So the point of this slide is basically saying data science is confluence of all these different things. Only when you combine all of these, you can extract meaningful and actionable knowledge from the data. Now, obviously, we cannot be expert in everything, right? And historically, from my work experience, maybe I'm a ETL guy. But then I know it's related to data science, and I know what other things are involved in data science. So maybe I learn a little bit of machine learning algorithms, and I learn a little bit about scaling up into larger data sets, learn Hadoop, learn Spark, whatever, right? So that way I can venture into a little bit of other things, and then I can become a better data scientist. And similarly, if you're a core statistician or a mathematician or a data analyst by experience, then you know what other areas to explore in order to make yourself become a better data scientist. And if you're a core software engineer who can create nice infrastructure, again, you know where what other things to look out for in order to become a data scientist. And this is what I meant by saying data scientist is kind of a role for many people, many types of people. Depending on what type you are, you have to venture into other areas and learn a little bit about those things. Okay. I hope that gave a kind of a comprehensive view on what exactly it takes to become a data scientist. Okay. And similarly, I mean, this is the same thing in a different way. Statistician, programmers, domain experts, and all those guys. And again, straight corollary of that slide is the type of skills that you require in order to become successful in the area of data science, starting from business acumen, programming skills, data warehousing skills, which are like data engineering stuff, and then business intelligence, starting from analytics and so on. And hopefully, uh, over the years, as the domain gets more and more mature, and as the technologies become more and more mature for data science, depending on the major focus, you may have a different role, right? A person may be a data scientist available, knowing all of them, but maybe his expertise is in data engineering. Maybe some other guy, again, knows all of those little details, but maybe expert in visualization, right? Depending on the core expertise, maybe there will be a different type of a role in the future. But currently, data scientist is about all of them. And that is because the domain is very, very new. Everybody is figuring out what exactly the roles should be. And since nobody has a clue, data scientist is supposed to know everything, and which is good and bad. It's bad because you need to make extra effort to learn a little bit of other things as well. But it's good because it's new. Since it's new, the bar is very, 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 very low. So it's easy to get into the field. Obviously, right? When it's new, it's very easy to get into the domain. And therefore you can grow in the field itself, as opposed to you grow and then join the field, which is what happens once the field becomes mature. Then you have to learn a lot of things in your training itself, and you need to have lots of project experience. Only then you will be able to start applying for jobs. But whereas now, since the bar is low, it's very easy for you to jump into this new career. Okay, and that's why if you have vague interest in data, and if you're excited about the type of applications that data science enables, then it's the right time to make that jump. Now, depending on the type of analytics that you do, there are different stages of analytics, um, uh, like starting from descriptive analytics, which is descriptive, diagnostic, predictive, and prescriptive. Okay, these are all the different type of analytics a data scientist will be dealing with. Descriptive analytics is basically about what happened so far. How do you describe the trend that has been there for some time? So it has already happened. You're just describing it in terms of statistics, in terms of trends. Okay, and then the diagnostic analytics is to deal with why exactly this thing happened. Why exactly the oil prices are plummeting right now, right? Why exactly the asset prices in US has been increasing. Now, predictive analytics is obviously, as the name suggests, it's able to predict what will be the oil prices in the next 1 year, next 2 years, next 5 years. Do we reach energy crisis like 1970, or are we going to go back to normalcy, right? So that's the predictive analytics. And even one step above is prescriptive analytics. How can we make something happen? How can we steer the oil industry, or I mean, we cannot steer the entire oil industry, but how can we make some changes and then get the result that we want, right? And there are already applications being created in all these types of analytics, right? For example, I mean, prescriptive analytics, uh, I mean, these applications are very, very new and may sound way across the real life, but they are there. And in the future, they'll become commonplace. Like, for example, in last year, every year there's this consumer electronics show in Vegas, right? Where all the companies will try to showcase their new gadgets that they have created, all the electronic companies and startups and so on. CES, that's a very, very popular, that's where all the new sexy TVs and new mobiles and new gadgets like Fitbit and stuff like that, they will get introduced for the first time into the market. Like there was last year, there was a product which some company, I don't remember the company name, but basically they have sensors in the spoon with which you eat food. Okay, and the sensor is gathering the data of how much food you're eating, how many scoops you're eating, and I mean how many spoons, and how full your spoons are. Are they half filled? Are they full scoop spoons that you're eating? And the pace at which you're eating, right? So it's collecting all the data about how you're eating. Essentially, it's tracking your eating habits. Okay, now it can just do the collection and then let you on your computer or tablet, it can show some nice trends. But that's about descriptive analytics. What has happened? How did you eat so far? That's it. But they also did something prescriptive. That means if you're eating very fast, then it will light some indicators or kind of show you some signals that you should slow down. Maybe eating fast will affect your digestion and maybe affect your health, right? I mean that might sound very, very. I mean, who will use that spoon uh, to eat every day and monitor your eating habits? At least I won't do, at least as of today. But you can see the type of applications that will grow, right? Especially with this new Internet of Things, everything is sensors, starting from my refrigerator, TVs, and all the gadgets that I have in the house, everything has sensors and they can all work together. And with that, you have loads and loads of data, and they can change a lot of things based on the uh, patterns that we observe. Right? That's kind of the prescriptive analytics. How can we make things happen according to some goal? Okay, and data scientists will be dealing with all these different stages of analytics depending on the project that they are in. Okay, and finally, applications. So we saw what exactly was data science and what type of analytics are there and what it takes to become a data scientist. And now finally, actually this should have been in the beginning, but since a lot of people already know about data science applications, I kept it at the end, which is simply the type of applications that you see in the real world. And as I was telling, it's cutting across all the domains, starting from retail, starting banking, insurance, healthcare, um, any domain that you take, right? Like for example, insurance. If I apply for a house loan, right, mortgage, how much should I get as a loan? And how risky I am as a borrower to the company, to the lender. And depending on that, the amount may vary, the interest rates may vary, the loan agreements, loan terms may vary. Lots of different things vary depending on my profile, right? And that's again, well-known application, but has lots of new trends, new twists to it, right? There are more data you can analyze to make that decision. Previously, they were analyzing only, let's say, my credit card history and my credit score and so on. But now they have a lot more data about me, about my financial profile, how I use my credit cards, and where do I use my credit cards, and how many accounts I have, how many investments account I have. All of that information they can put together and then analyze. Am I paying my library dues in time? Right? All that information is kind of telling me, telling the bank about my behavior, and that will be useful. And how am I interacting with social media? Even that's people are looking at, right? So even though it's a classical problem, there are new twists in terms of new types of data, new types of analytics, and new types of insights. Right? So there are new applications like the ones I was talking about in terms of tracking your food habits, and there are old applications with a new twist, right? And in terms of well, all the companies that you can think of, they will have problems relating to data science. And yeah, in terms of the roles, I get you got an idea from that slide from this thing, right? Different types of roles depending on where the focus or where your expertise lies in. Okay, but nevertheless, I strongly urge you to learn from other areas in this picture. I mean, of course, you cannot get domain expertise until you work on it, but at least you can look at visualization, statistics or mathematics, data engineering, and advanced computing. Depending on which bucket you are in, try to explore the other buckets. Okay. Now, with that, I will so some more applications, like for example here, BMW is using predictive analytics to find a parking spot. In a huge parking lots, it can find you where exactly is it, and you can directly go and park it there, right? And similarly, e-commerce recommendations. Any retail company like Amazon and Walmart and stuff like that thrive on recommendations. In fact, that is the example that I'm going to show you next. Okay, and so on. Many applications in terms of creating profiles of your customers to understand their purchasing behavior, or if you are a telecommunication company, you want to analyze this churn prediction. It's a very, very classical application in telco, telecom industry. Churn prediction is churn refers to people who are leaving your service, right? And we know that changing a cell phone carrier is very, 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 very easy. Switching from Airtel to Docomo or something else, it's very quick. Just change the SIM card and you're done. And so the chance of leaving your service is, or the ease of leaving your service is very easy. And therefore, these companies try to predict that churn, who is likely to leave the service, and then maybe try to take care of that business, right? So the churn prediction also kind of falls into interesting application of data science. Okay, so we can talk lots and lots of applications in healthcare and other things as well. But let me show you a quick demo of recommendations. Okay, we know recommendations, right? How important they are. Like if you take companies like Amazon, Flipkart, and those kind of companies, their main business is in recommendations. Once you buy your product, they will recommend saying that, oh, if you like this product, you may also like something else. Or people who bought this product also bought this one, so maybe you want to check it out. Or some targeted advertising, right? If I'm buying lots of baby products, maybe they will send me a coupon for trying out a new set of diapers, maybe, right? Or give me a coupon for, I don't know, body wash. So that's recommendations in general. It it can encompasses a lot of different types of recommendations. Not just retail, even in online streaming video business. I don't know how many of you are familiar with the Netflix company. Anyone know? I mean, in US, probably people know about it already. In India, you may not be familiar. Um, So Netflix is a video streaming company, right? I subscribe to their service and I can watch movies and videos and TV shows, documentaries, and stuff like that online in streaming manner. Now, recommendations is their bread and butter. If I'm watching lots of action movies, then they try to recommend more action movies to me. Or if I rate some movies very, very high, based on the genre and the type of movies that they have, that I have rated very high, they will recommend some other movies to me in the similar context. And they will also try to find similar users like me based on the things that I have been doing on Netflix. They can figure out that, oh, uh, me as a user is very similar to some random guy in China, let's say. We both have similar tastes. We don't know each other, but Netflix knows that we too have similar tastes. So if that Chinese guy, let's say he rated a movie very, very high, which I haven't seen yet, then Netflix can basically recognize the fact that we both are similar. So since he liked that movie, I may also like it. So it will recommend that movie to me. Okay, so there are lots of types of recommendation, and let me show you a few types of recommendations that we can do. And if you're familiar with Netflix interface on the website, you will be able to relate to exactly the type of things that I am going to show you now. Okay, so for this, I will look at the data from this public data set called Movie Lens, which is exactly like Netflix data, which is about users and movies. Okay, so there are a bunch of users. Let's take a very small data set just for the demo purposes, but there are larger collections available as well. Okay, in this small data set, we have about 100,000 ratings. Okay, users will rate movies, right? Rate 4 out of 5 or 5 out of 5, 3 out of 5, whatever is star rating. So there are 100,000 ratings given by approximately 1,000 users and on 1,700 movies. Okay, that's my data. And it looks like that. Actually, let me show you the data on the downloaded version. So I'm going to use, for this particular demo, I'm going to use Mahout, which we will learn in the data science class for a couple of classes, couple of sessions. Okay, Mahout is this machine learning component in this Hadoop framework. Okay, Hadoop is this big data software or a framework, and it has many components in it. And one particular component is called as Mahout, and this is geared for doing machine learning on large data. Okay, so let's see the data first. Okay, let's see where it is. Okay, this ML100K. ML100K is the data set that I just showed you. Movie lens, small data set, 100K. That's what if you download this one, that's what you get, ML100K. Now it has bunch of files, but we will focus on only a couple of files, which is u.data. So your data looks like this. 4 columns: user ID, movie ID, and the rating and the timestamp. Okay, so this means user 196 has rated movie 242 with the rating of 3 at so and so timestamp. Okay, similarly, I have so many ratings, total of 100,000 ratings across multiple users, across multiple movies. Now, this is the data I've been collecting on my, let's say, website like Netflix. Okay, people are watching movies, rating them, and then I've been collecting that data. Now, with this data, how can I build a recommendation engine? Now, obviously, I have more information about the users and movies as well. Like, for example, u.user will give me some information about the users. The user ID, the age of the user, 24 years, male, and his occupation is technician, and he lives in this particular zip code 85711, postal code. Okay, some other, obviously Netflix will have much more information about users, but let's say this is my user information. And similarly, I have item information as well, u.item. Item means movies here, the products. Okay, it looks like that. Oops, sorry. I have the movie ID and the movie name, the release date, and some IMDb URL, and a bunch of flags indicating the type of movie, the genre, right? If you look at the README file, you will see u.item, information about items or movies. Okay, what does it have? Movie ID, movie title, release date, video release date, URL, and the genre, whether it's an action movie or an adventure movie or an animation movie, documentary, crime, and so on. Right? So this is some movie information. So we have the movie information, user information, and the ratings. Now using this data, we can now start by creating recommendation engines. Okay, so let me show you, I mean, without showing you the actual mechanics of it, let me show you what kind of output you can get by simple few lines of code. Okay, and this we can do that from command line as well, but I'm going to show you from Java application. Okay, so this is a code I have written, which is it uses Mahout functionality to create a recommendation engine. Okay, in as simple as these 3 lines of code. That's it. Those 3 lines of code creates a recommendation engine called recommender. That's my engine using the data that I just showed you. Okay, now using this recommender, you can make lots of different types of recommendations, which are exactly like what you will see on websites like Netflix thing. Okay, let me show you some examples. So this program takes bunch of parameters. Essentially, it takes these. I'll give it the type of recommendation that I want and the relevant arguments. Okay, so first let's see one simplest type of recommendation, which is given a movie ID. and a user ID estimate the rating. Okay, so for example, uh, I mean, I just logged into Netflix, and now Netflix has to figure out whether, for example, if it has to recommend the movie Titanic to me or not. Okay, so for that, what will it do? It will basically estimate the rating. What would be the estimate I would give to movie Titanic based on my history? Okay, so there I have the user ID, which is my user ID, and I have the movie ID, which is the Titanic. And between these, given these two, I need to estimate the rating, predict the rating. And that's what we are going to do. Estimate the user ID 20 and movie ID 1. Okay, one happened to be the Titanic movie, I think. Sorry, Toy Story. Okay, so I want to see what is the estimated rating for the user 20, the movie Toy Story. Okay, so I can just run it, and it is estimated to be 3, rating 3 out of 5. Now, depending on how you interpret that, the service may like to recommend it, or even when I click on Titanic, it will show, like, again, if you're familiar with Netflix interface, you will be able to relate to this. Whenever the user clicks on the movie Titanic, it will show you the estimated rating in terms of stars, and there I will show 3. Okay, so that's one type of recommendation. Given a movie, given a user, estimate the preference. Oh, sorry. It went into mute. Um, Sorry. So let me repeat what I was just saying. So the first type that I showed you, given a movie and a rating, given a movie and a user, you predict the rating, right? That's one type of recommendation. Now, there are other types of recommendations as well. Like, for example, whenever the user logs in to your service, you want to show some generic recommendations, some top 5 movies that you want to recommend to that particular user. Now, this is a different type of recommendation, and this is exactly what you will see on the Netflix website as well. As soon as you log in, you will see top picks for your user, right? So my name is Shiraj, so it will say top picks for Shiraj. As soon as I log in, it will show some movies. Now, how does that happen? The same recommender object that we created here, the same recommender object can be used to create a different type of recommendation as well. Like here, I'm showing this top 5. Okay, given a user ID 20, give me top 5 recommendations. Okay, so when I run it, I'll get something like that. Top 5 recommended movies for the user 20 or so and so. These are the top 5 and these are the estimated ratings, right? So like 1662 is actually a movie, Rough Magic. And similarly 1191 is another movie, Letters from Death Row or something. I don't even know what that movie is, but it shows you some movies that you can directly show as soon as the user logs in. That's a different type of recommendation. Okay. And Netflix or any other service gives you a different, yet another type of recommendation, which is, let's say I go and click on a movie and add it to my list. Okay. Now, as soon as I add the movie to a list, it will recommend 10 different movies related to this movie that I just added to my list. And similarly, on Amazon or Flipkart, you can think of the same thing. As soon as I purchase purchase a product, it can recommend some 5 different products that are kind of related to the product that I've just bought. So here, so in the first setting, we have both the user and the item in the context. In the second setting, we just have the user in the context. Given a user, give me recommendations. Now in the third context, you just have the item in the context. Given this item, tell me all the similar items that are there, so that I can start showing to the user, right? So that's a yet another type of recommendation. Similar items. Okay, give me sim 5. That means, I mean, that's just a code I created. Sim 5 basically gives me 5 items similar to this movie number 1, which is Toy Story. Okay, so I'm asking, give me the best 5 similar movies to Toy Story, so that I can recommend to the guy who just watched Toy Story. Okay, so I'll get some movie IDs. So let's see what they are. Item 50, they are Star Wars, and 121, Independence Day, and so on. So these are the movies that from the data, it saw that they are related or they are similar to Toy Story. And therefore, it made a recommendation. Now, this should right away kind of uh, raise a question in your head. Why Star Wars and Independence Day is closely related to Toy Story? Toy Story is a children feel-good movie, animated movie, whereas Star Wars is a sci-fi movie. Independence Day is full-on action movie. Why these movies are related to Toy Story? If I'm doing just from my brain, I wouldn't pick those two as the most similar movies. But by analyzing the data, you can figure out that whoever liked Toy Story, they rated similarly to Star Wars and Independence Day as well. If somebody hated Toy Story, the same person hated Independence Day as well. And if somebody really loved Toy Story, the same guy rated very high for the Independence Day as well. And therefore, it sees the correlation between the type of ratings that these two movies have got. And therefore, it finds that the rating pattern is same. Even though the genre of the movie is different, the rating pattern is same, which you cannot find by just looking at the data. You can only do that by actually analyzing and figuring out some model under the hood. Okay? And these are only very simplistic model I've created. And there are lots of sophisticated recommendation engines that are possible, and that's what companies like Netflix, Amazon, um, those kind of companies use. And the similar techniques, you can use them for advertising as well, right? Recommendation is also kind of advertising. If I have like 10 different types of coupons to distribute, whom should I give? That's also kind of can be posed as a recommendation problem. Okay, And in the class, you will be learning about these building recommendation engines. What is the math? What is the core technique behind it? Once you know the technique, it's a matter of implementing it. Like Mahout already gives you a way of implementing it very easily. But even if some new software comes in tomorrow, once you know the core technique, you can implement right away. Right? So that's what you will learn in the class. We will look at different applications and the underlying technology or technique that powers that kind of analytics. And we'll see at great length on predictive analytics. Like the diabetes example that I showed you is actually one of the data set that we deal in the class. It's a toy data set, but nevertheless, you will be able to create a model which can predict whether a particular patient has a risk of diabetes or not, given the health history of that particular patient. And you will be able to, you will learn ways to evaluate whether you're doing the right thing or not. Even the recommendation engines. I recommended something like these 5 movies, but is it really a good model? Right? Unless I ascertain that this model is the right thing, is the good model, I cannot uh, build my business on something that I don't even know that works, right? So whenever you build a machine learning model or a data science model, you need to make sure that it performs very well as well. And that's the quality assessment. And we'll see that angle as well. So in the class, we will basically see many types of models, starting from clustering, classification, recommendations, and a couple of others. And against each of them, we'll learn multiple techniques under the hood, and we'll play with example data sets to see how we are doing it or how we can apply these techniques in real world. And we'll also learn how to assess these models, how to assess the quality of these models. Okay, so all these things you can learn in the class. Now with that, I'll kind of close the session. Basically, just to recap, we have looked at what exactly is data science, what type of components that are involved in data science, what type of technologies, right? And what kind of analytics are there? And then finally, we looked at one small application of recommendations. Okay. Now, with that, that's all I had to say. And I hope that gave a good and quick introduction on data science and gave you a sense of what that is. And I hope you got excited by uh, uh, those couple of little examples. Now I'll open the floor for questions. If you have anything, please let me know. And we can take like 5-10 minutes for question and answers, even though it's already kind of way over the time limit. What can we expect the course that you have mentioned? Oh, where can we expect? Oh, that's the data science class that is offered by Edureka, and I will teach that class. Okay, and the interface what I've shown is Mahout. Yes, that's the Java interface of Mahout. Yes, Sajid, that's why I said Mahout has multiple interfaces, but I shown you Java. There's also command line interface as well. So even though you're not a Java person, don't worry. Data science does not mandate you to know Java. It's a plus, and over the time you can learn it, but it's not a prerequisite. what should be the step one to do enter into the data science field? Well, you already took step one, attending the webinar. Step two will be taking the class, and after that you will be able to see whether you can really fit in or not. And I'm sure everybody can fit in because of this confluence of different fields. What are the required languages to know data scientist profile? What are the So that's a tricky question because as you saw, it's a confluence of many things, right? And therefore, there are lots of different technologies and languages involved in it, like R, Python, Hadoop, Spark, Pig, Hive, blah, 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 right? So there are multiple varieties, and nothing is like a strong prerequisite, right? It's good to know multiple of them, but some organizations might be using Python, some other company might be using R, right? So there's no one answer to that question. What are the courses come in data science? SAS and R, Excel. Not sure I understood your question, Satish. Data science is a class that edureka offers. Okay, if you want to expand on that question, please do so. I think you kind of made a UDF in Java. Is Java a needed component? I guess I answered that question. Pig and Hive guy. Oh, very good. You fit in right there. Um, what are the basic languages to be learned about big data? Again, I hope that answers the question. There are multiple of them, so there's no one fixed thingy. But in the, I mean, actually, since that's kind of the common question that I'm seeing, in the class, we will learn R and we'll learn Hadoop, at least the machine learning side of Hadoop, which is Mahout and other things. Okay, and we'll also learn how R and Hadoop can be interacted with each other as well. And we focus on R because it is gaining a lot of popularity in the market right now. And in the class, we'll see what kind of market trends are there and stuff like that. But with that capabilities, you can go into the market and apply for positions or take some data scientist certification and stuff like that. How many hours a day and how many days course is it? Good question. Um, we have 10 sessions. Each session is of 3 hours. So total of 30 hours. And it's spanned over 5 weekends. Okay, I learned Hadoop but didn't get a chance to work in real time. Can I go ahead with the data science? Absolutely, without a question. I wanna know, doing course is enough to get a job, or we have to go to some post-graduation in data science. So I know a couple of people who landed in data scientist jobs right after the course. But I mean, don't think of the end goal right away, right? I mean, since this is new to all of us, just take the class to understand what this thing is. And at the end of it, you will be able to really assess. Obviously, you can judge only when you know it properly, right? So at the end of the class, you will be able to assess yourself and your interests and so on, right? But again, depending on the job description, you may be able to get the job right away, and sometimes you need further work as well, because I mean, in the class we'll discuss that there are tons of different techniques, and obviously within 30 hours of lecture we cannot cover all of that. We'll cover only the most popular one in different categories. And the goal of the course is to give you the breadth of uh, um, techniques so that you get an exposure of what kind of things are there. But there are lots of other things that to be learned as well, and that you can pick up after the class. Okay. Could you please explain what type of roles and responsibilities of data scientist in project? Again, like as I said, it involves massaging the data, creating mathematical techniques, which are well known. So you just need to understand them and how to apply them, and then visualizing and stuff like that. I don't know if that answers your question, Karunakar. And math knowledge, math or statistic knowledge is required to learn data science. Yes, because that's an integral portion of it. And you just need to understand some basics of those techniques. Okay, at least to become an entry level data scientist, you just need to understand the basics of these techniques and how to apply those techniques. That's sufficient. And only when you reach a very sophisticated level, that's when you can create your own methods as well. But that requires a lot of expertise and lots of time, and that comes only with time. You cannot right away become a person who can create a new model on your own, right? So at the beginning level, you just need to understand what is there and how to apply that technique. I'm from banking domain with 8 years of experience working in Oracle. Is this data science recommended for me? Absolutely. You have the financial background or the domain knowledge as well as data working with data. That's a killer combination already. If you're not from math background, how will we go with it? Again, as I mentioned, um, in the beginning, you just need to understand the technique and how to apply it. You need super high level of mathematics only when you want to create your own thing, which will come way later in the time. Is this online or classroom? Well, it's an online. The session will be like this one, the webinar. What is a course fee? You can get the Indira, you can get the information on Edureka website, and they have lots of deals as well. Buy one course and get one course free and stuff like that. Yes, and edureka is an Indian company, and therefore you will be paying in Indian rupees as well, not in dollars. Again, uh, since another common thread of question is this the right thing for me, right? So for that, I'll just leave you with this slide. You figure out which bucket you are in. If you're a data scientist, maybe you are in here. If you're a ETL person, you are in here. If you're a core software engineer, you may be here, right? Depending on where you are, it's if you fit in any of these buckets, it's for you, right? One person said they have domain knowledge, then you fit in here. If you fit in any of these boxes, then data science is right for you. All you need to do is open up your box and look at the other boxes. Come out of your box and look at into others. At least peek into others. Did I answer all the questions? Did I miss anything? Or any other questions you have? Okay, very good. So this entire webinar will be made available online as well. So you can watch it later on if you need to. And yeah, that's all I have to say about data science. Um, I hope you got a better perspective than when you started the class or started the webinar. And I strongly encourage you to give the course a try. It's only 5 weeks, 5 weekends, 3 hours every session. It's not much time. And if 30 hours can change your career path, why not? Why not give it a try, right? So just give it a try, see if you really find it interesting or not. And I'm sure if you keep your mind open, I'm sure it will be of interest. And not just interest, but it will be useful field in the future, in the very near future as well. So you can really kind of reap the benefits out of data science in near term. When will it? Yes, the PPT will also be available, Satish. And the classes, there are multiple batches. Again, you can get all those information online. When it starts, what are the timings, what is the duration, what's the plan of the class, and stuff like that. Um, do you teach any data visualization also? Actually, no. In the class, I don't focus on visualization because that's something you can easily pick up. Uh, Whereas the other things like mathematical techniques and other things need some explanation. You need to be able to see the intuition behind the technique and learn how to apply it and stuff like that. I mean, that's not taking anything away from visualization and the complexity of it, but it's something at least you can pick up, and there are other courses also for doing that. And therefore, I do not touch upon visualization at all. Okay, very good. Thanks, guys. Thanks, everyone, for joining the webinar. And I hope many of you will consider taking the class as well, and hope to see you in the regular sessions. Bye, everyone, now, and good luck in your careers. And I hope you give data science a chance to make your careers more exciting.